All right, everyone, welcome. This is part one of lesson 6.7. This is the last lesson in the exponential relationships unit. Today, our content objective is to find the independent variable when the exponential model exceeds the linear model by using a graphing calculator to find the point of intersection. So let's look at what we're going to do here. So suppose that you are offered a job that pays you $1,000 the first month with a raise every month after that. You can choose either a $100 raise, or we're going to change this. This is going to be a 1% raise. Which option would you choose? Okay. So for job A is $1,000 for the first month with a $1,000 raise every month after that. So as a function, that's going to be very, very linear. That's going to be y equals 100 times x, right? The number of months, plus our starting point, which is 1,000. Job B pays $1,000 for the first month with a 1% raise every month. So now y is going to equal 1,000, our starting point, times 1.01 to the x power. That's our 1% raise. So those are our functions. That's what it says. It says write the functions that represent the monthly salary. So there we have it. And then we're going to use a graphing calculator to actually graph this. So here's our graphing calculator. And what we're going to do, I'm trying to do this with as little glare as possible. There we go. So we go to y, and we can put in our two equations. You can see now that I've already done that. I've got y is equal to 100x plus 1,000, and then y2 equals 1,000 times 1.01 to the x power. Make sure that both of these equal signs are highlighted. That way it will do both. But before we graph, we also need to give ourselves some minimums and maximums in our window. So over here, let's talk about that. Now this is something that it's going to take you time to get good at, okay? Like what these values should be. So we want y minimums and maximums and x minimums and maximums. So x minimum, it's always good to just start with 0. Y minimum, well, we know it's going to start at 1,000 in both of these, so we'll just start it at 1,000. Now, as far as the Y maximum, this is where it gets difficult. I kind of already have a good idea of where this is going to go, partially because I've already done this, but so I'm going to call the Y maximum 400. But you could go higher, you could go 500, 1,000. Just depends on how accurate you want the graph to be. And then the Y maximum, well, we're starting out with a salary of 1,000, so I'll go up to 50,000 just for now. And you could do small. You could try 10,000. You could try 25,000. But when you go to graph, if those don't work, go back and try it again. Okay, so I go back to the calculator. So I hit window where I can put in these values. Shading resolution, I'm going to leave that at 3. Notice I've got the x minimum at 0, maximum at 400. The x scale, right now it's at 10. But I could do smaller amounts if I really wanted to. It's just going to take longer to move back and forth. Y minimum's at 1,000, Y max, and then we have the Y scale at 10 as well. And again, I can make those different values. And now I can graph. So I'm going to hit graph, and this is the graph that it gives me. And we can see here, this is that first function, 100x plus 1,000. This is the exponential function. And then if I hit trace, I can move along one of these lines, and really I only need to move along one of these lines. And so I'm going to move until I get right about, and remember every x value is a month, until they intersect. Right about there, x is equal to 365.95745, so I'm going to call that 366. So now when I come back here and I graph, if I want to build just kind of a quick crude graph, one line is linear, The other line is exponential, but eventually they do cross at this point, and at that point x is going to be about 366, and y is going to be about 38,000 or so. We'll say 37. Say about 37,000. I don't know. Let's just call it 600 for right now. And so that would be the salary at which those two meet if we're estimating that. Okay.